Okay, so remember, for somebody like the bluestone masons, we don't use air turbulence in the way you commonly use an air turbulence equation or aeronautics. Um, Remember, in the stone mill, you are a particle equally like the saws are, and they move with turbulence in these places. The difference is, instead of using a, a variable, I'm just relying on a specific form to give me not calculus points, but scaled functions. Um, I'm trying to smooth this turbulence that is the force of time across this system. So AU, derivative U is again a calculus standard against X. Once you apply that X to a situation, saw, person, saw with a person that works that saw, they're not, they don't give you the derivative. You have to limit that calculation and then apply it. Me, the saw, me and the saw, me and the saw in this company. And so you're working that. And as soon as you figure out that's what that material is, you're standing in the hurricane. So we apply that number in such a way. Um, when the Big Bang, this rapid model of expansion, happens inside of the system, you get that first. Is it you? Is it the saw? Is it you and the saw that determines what the mass is, what the dark matter is on that calculation, what the total elements, everything in the observable that we can't even really know. We're just approximating. The numbers work, but we have holes with those things. They work to the physics, but they don't work to all the physics. And if you look at AU, AX, it works to all physics, but it doesn't work to the specific physics that you're dealing with. So for guys like us, we didn't go weather forecasting. We didn't go meteorologists to understand air turbulence equations. We didn't go in the aeronautics field to deal with acoustic flutter of the vibration of the materials. We go to understand the C-16, right? That's a type of plane. And how far does it go? The speed in which we go. The time when we leave with that C-16 to drop a bomb, or people and units and paratroopers and so on and so forth. Um, because in the same way, if you get that wrong, you're forecasting on the time, or how many units you send, or what's the material you do and how long that will last between rotations of C-16s dropping supplies and other variables. Because if there's ground units moving in here, then you're off on costs on things. And of course, this matters. Uh, I mean, I love the air tunnel as a common whole, but if that's the only place you'll ever understand Nova Stroker's air turbulence equation, you're going to be hurting. It's because that's the only place you'll ever be able to use it. If if you only stay in the idealistic idea of what weather forecasting is, then you'll see hurricanes. And the augmented physics to a meteorologist that has amazing physics and that ability will lose it for costs and times. Now, I'm not telling you that that's a bad thing in the stone mill. I'm usually pretty focused on what I'm doing too. Um, hear that last video with Corona where a guy had it on the whiteboard talking about hypoxia, apoxia. I don't study those terms. They're filled into different positions for me in the stone mill. Guys, units, social behaviors, the psychology, the mechanics, the engineering, the electronics, servers, resistors, capacitors. They actually file a physical position equally to a quantum state in the way they're applying in the room, and in some cases, a bit of both. Um, you are a physical resistor. You have physical resistance. Doesn't feel like much of a very weak force while you're dealing with it, unless you're actually standing in a hurricane or living on top of the mountain, because that's a whole different animal. Uh, Heavy as the ground, right? Take a look. Say something dumb about the National Guard? Oh, you might as well just hang it up. Throw yourself on the sword, brother. You just lucky enough you didn't say anything. You just said something dumb. You didn't actually have, come out, oh, well, you're banging hookers and. 6 feet doesn't seem like it's anywhere near enough. You think that makes it farther than 6 feet? Well, it's about 6 feet away, and I definitely see those little leaves moving on that fig tree right there. So you're standing in the dollar store, right? For where somebody was just walking around, and that's them just standing there. Let's have them be a physical body. Let's go to that air turbine or the wind tunnel again, and just instead of blowing the wind against it, let's take one person and walk them down an aisle while they're breathing. So not only is it directly in front of them, but they're making a wake for themselves that disperses it even farther. You shouldn't be afraid of this, especially considering what it is. We're already under social distancing rules for what it is, and we have a big problem. We have a big problem with people not giving a fuck and just not properly informed under any standard. We all individually have our tasks, and we hope that a system represents that I don't have to understand aeronautics at the level of, well, I get aluminum's light, and I don't want to have to redo this with what I think is the best materials because my welding skills not necessarily are bad, but because the housing and the structure isn't perfectly engineered, you got to put more weight to it so it holds it together. So you got to put a huge engine in that just pour efficiency on that. So you learn the better parts, you make a better motor. If you've actually studied Nova Stroker's equations or air turbulence as a whole, what are they doing in those wind turbines? They're trying to understand that lift, that drag of that plane's or the plane's wings. They're trying to understand the shear force of the wind in small scale on a skyscraper, so they can determine the topography of that area to say the materials, the cost, the timelines, the adjusted physics before we start to build it. And it's just honestly, the idea of what Corona is out there is as bad and one half as what the rest of this is. And the truth of the matter is, what quantum physics is and what polarization is and polarized wave functions are is something that we have to go ahead and begin to level the curve off with this as well. I wish we could do individually the focus on one without the other, but while we have a situation like Corona out there, there's no reason that we can't backbone it as a second order operation to everything that is in every way: the hospitals, the government, the military movements, cultures, and how we have to define this court case of China suing us and we're suing China from Florida. I mean, as bad as it is, China fucking shit up Florida, South Dakota, go South Dakota. Just get somebody from South Dakota, drop the suit, go right into South Dakota and do it. But for you in Florida to make that claim, even though you're not that person, you're just one person in Florida, damns your case. You can't see that air turbulence, you can't see the friction and heat loss, voltage, energies of that plane that you're building that's, well, probably heavy duty, built with extra supports and systems that have to go into that. You could have had that same effect at a better cost, especially given the time space. This is an air turbulence equation, AU over AX. This is the calculus forms over this position. It applies AY given multiple variables, or AX plus BX, given the first order, or an AX plus BY, affecting in the first order and applying in the second order, given laser calc and higher orders, higher energy states. They're basically equal, but by relative physics, costs for one might be at a higher level at an equal plane. So we're dealing with first order and second order operations. this one costs 5, that one costs 5, and this one costs 5, but it's not 15 as a total whole as you add them together. It's some offset algorithm of what that represents. But don't get too beat up on the math. That's ones and zeros. Look at the standard model. Look at the little numbers. Why do they all say 0 and 1 and -1? But when you look at the periodic table, 1, 2, 3, 4, 5, 6, 7, given their atomic weight. Now, in the same regards, that's referenced in the same way. What are they doing? What's the difference between up and down in relativity? And if I was at the South Pole and I was just relative to the time on Earth, then yeah, up is down. If I was on the North Pole, I'd be orientated like this, and down is down. South Pole, up is down. Given how I'm positioned at it in an orbital around this, maybe I'm facing this way, maybe I'm facing this way. If you were orientated correctly, you would hear a charm. This little sensor going, hey, the EM field says that's what it is and this element's in there. But even if it was just the short order operation, oh, got to turn around first. If you miscalculate that because that was the moment when you need it and you were just in the wrong opportunity, that bunny hops out and you miss it with your longbow. It's that simple.